The instruction set architecture defines how the CPU operates. A programming model includes all of the bits that the programmer can see and manipulate. CPUs have many registers and many bits internally that the programmer cannot see. Programs operate on values in registers in the CPU. There are several types of registers. General purpose registers are used for a variety of tasks in a program. The program counter points to the location in memory where the current instruction resides. Status registers may record the results of operations that are performed in the CPU. Some architectures provide special purpose registers, for example, for digital signal processing. Instructions can operate on several different types of operands. A register operand, an immediate operand, is given in the instruction itself. One of the important things that programs do is calculate addresses. There are several different forms of addresses. A relative address is relative to an address given in a register. A PC relative address is relative to the program counter. An effective address is the final address after any address calculations. And an absolute address is an address in memory. Let's use some examples to illustrate address calculations. The relative address given for x1 and the immediate value 4 is the value of x1 plus 4. The PC relative address for the program counter value and the immediate is a different value. The PC relative address is calculated based on the value of the program counter and on the immediate. We'll use the RISC-V instruction set architecture as an example of how instruction sets are defined and used. RISC-V has many variations. We'll concentrate on some base integer instructions. Instructions are word aligned, so we could start an instruction in byte 0 or byte 4, but not in byte 2. RISC-V provides 32 general purpose registers, x0 through x31. x0 always holds the value 0. These registers also have other names for specialized uses that they provide, but we'll use the X names for the most part. The program counter is known as PC. We'll deal with 5 different formats for instructions. Each format defines the layout of bits in an instruction. We'll go through some of the major instructions and show how their bits are organized in the instruction and what the instructions mean. The load word instruction includes a source register, an offset, and a destination. In this case, the source register is x4 with a value of 27. The offset is 9. We add together 27 and 9 to get a location 36. We then fetch the contents of location 36 from memory and put them into register x6. Store word has 2 source registers and an offset. The second source register, x6, holds the value that's to be written into memory. The first source register, x4, and the offset, which is 9, combine to give the location that the contents of x6 are to be written into. The add instruction operates on registers. We have 2 source registers, in this case x5 and x7. We add the contents of the 2 source registers and put the result, which is 20, into the destination register x2. An add immediate adds the contents of a source register, in this case x5, with an immediate value. In this case, we add 16 and 9 and put the result into destination register x2. The XOR operation operates on 2 registers, in this case x5 and x7, and puts the result in the destination. Here, XORing together the values 7 and 5 give the result 2. A shift left logical has 2 source registers, one that gives the value to be shifted, and the other the amount of the shift. The result is put into the destination register. Here we take contents of X5, which is 4, shift by the contents of X7, which is 2, which gives the result 16 that's written into X2. The SLTI instruction compares the value of a register, in this case X5, with an immediate. Here the contents of X5 is 16, the immediate is 9, so the test 16 less than 9 fails, and we write a 0 into the destination X2. Jump and link instruction is used for function calls. It computes a return address for the function, saves it, and then changes the program counter to go to the function. The destination register is X3. We load into the destination register 4 plus the current contents of the PC. We then change the program counter by adding the immediate value. The branch if equal instruction compares the values in the two source registers, in this case X2 and X3, and if they're the same, it adds the immediate to the contents of the program counter. An exception is an unusual condition detected at runtime. A trap is an action that the CPU takes to handle an exception. Typically, an exception causes a handler, a software routine, to be called. In some cases, an exception may cause the CPU to halt. Execution modes are important tools for providing computer security. RISC-V provides 3 execution modes: a user or application mode, known as U, a supervisor mode, or S, which has more privileges, and the machine mode, or M, which has the highest level of privilege. We can build an instruction set simulator to help us both understand the operation of the instruction set and to perhaps debug some code. This simulator will operate on a very basic cycle. It will fetch an instruction from a simulated memory, decode that instruction, and then operate on a simulated register set in order to simulate the results of that instruction. We can write a C program that simulates the instruction set architecture. It doesn't provide any information about timing, but it does help us understand functionality. We can use variables to define things like the program counter, the register file, and so forth. Memory is represented by an array of words. The simulator loads a program by reading it from a file and placing it into the array that simulates memory. It then repeatedly fetches a simulated instruction, decodes it, and executes. The operate function provides the main functional simulation. It extracts an opcode from the instruction using bit manipulation and then uses a switch statement to select the appropriate code to execute that instruction. For example, the add instruction will extract out the sources and the destination, perform an operation on the register file, and update the program counter. Thanks for watching.